So we're on page 73, and the problems we're going to do are 15, right here. Going to move to 18. Here, we're going to do 22. And from 23, we're going to do two parts, B and part F. So let's move to the first problem, number 15. Here we're asked to find three consecutive odd integers such the product of the first and the third one is 7 more than 10 times the middle one. That looks like quite a sentence, and we have to unravel it. But first thing we're going to do is say that the first consecutive integer, and it's going to be an odd integer, is going to be x. The second one will be 2 more than that, and the third one will be 4 more than the original. For example, if I start with the number 5, I have to add 2 to come to the next consecutive integer. 5 plus 2 is 7. And then I have to add 4 to come to a third one. 5 plus 4 gives me 9. So 5 would say represent the first one. 5 plus 2 would be 7, the second one, and 5 plus 4, 9 would be the third one. So now what we want to do is look at, once we've established how we're going to show these three, x plus 2, and x plus 4, such that the product of the first and the third. So here's the first, and here's the third. So I'm going to multiply x times x plus 4, the first times the third, is 7 more. So it means it's too much by 7. I'm going to subtract 7 from it, and then here is the equal sign, 10 times the middle one. So here is 10 times the middle one, x plus 2. This is the middle one here. Now if you want, you could, instead of subtracting 7 from the left-hand side, you could add 7 to the right. So that's another possibility, but I've left the 7 here. So now what we're going to do is multiply by the distributive rule. X times x gives me x squared. X times plus 4 gives me 4x. Minus 7 is this term here. Using distributive rule here, 10 times x gives me 10x. And 10 times plus 2 gives me plus 20. So now I'm going to bring all terms to the left. The x squared stays as it is. I've got plus 4x. When I bring this from the right side to the left, it becomes minus 10x. 4x minus 10x becomes minus 6x. And plus 20 on the right becomes minus 20 on the left. So minus 7 and minus 20 gives me minus 27 equals 0. So now I factor this, and the factors are, first of all, x times x gives me x squared, and the minus 9 times the plus 3 gives me the minus 27. The inner term, minus 9x plus 3x, minus 9x plus 3x are combined to give me minus 6x. So those are the factors x minus 9 and x plus 3 equals 0. I set x minus 9 equal to 0, and I get x equal to 9. Or I can set x plus 3 equal to 0, in which case I get minus 3. So if x is 9, x plus 2 is 11, and x plus 4 is 13. So 9, 11, 13 are the three numbers. Or we start with minus 3, we add 2, we get minus 1. If we start with minus 3 and add 4, we get plus 1. So it's either this possibility or that possibility. So now I check the answer for 9, and I go back to the original equation, which is right here. Here's the original equation. Okay. And I put it back into the original equation. X is 9. Here I put 9. I get 9. 4 plus 9 plus 4 is 13. 9 times 13 is 117. And I subtract 7, I get 110. So 9 plus 4 is 13. 9 times 13 gives me 117. 117 minus 7 equals 110. You can do that on your calculator, but look at the right side. It's 10x plus 2, and x is 9. 9 plus 2 is 11. 10 times 11 is 110, so the right side equals the left side. Now, if I take minus 3, and I do the left side over here, this is minus 3. I place this x, minus 3 plus 4. So that gives me minus 3 times 1, which is minus 3. And then I subtract 7, which is, of course, taken from here. And I get minus 3 minus 7. I get minus 10. The right side is 10x plus 2. Minus 3 plus 2 is minus 1. 10 times minus 1 is minus 10. So I get the right side equal the left side. So if you want, you can say, now, okay, let's look at this. 3 consecutive odd integers such that the product of the first and the third. So the product of the first and the third is 9 times 13, which is 117, is 7 more. So if I subtract that, I get 110. 10 times the middle one. The middle one is 11. So that's 110. So you get the same answer that way, and you can do the same thing with the minus, the other answer, minus 3, minus 1, and 1. Okay, number 18. The sum of two numbers is 12, and the sum of their squares is 12. Find them. So what we have here, what we do is we let x equal the first number. Okay, we know that the sum of two numbers is 12. 12 minus x must equal the second number. Let's say, for example, that the number, I'm not saying what the answer is going to be, but let's say the answer was 3, the first number. Then 12 minus 3 must be the second number, because 3 and 9 gives you 12. So you can always use this kind of technique when you know two things, what the sum of two things is. Then you identify the first, and the second one is always the total minus the first. Notice that when you add x plus 12 minus x, the x's cancel, plus x and minus x cancel, and you're left with 12. So now, the sum of their squares. You square the x, which is the first number, and you square this, you get 12 minus squared, and you're told that that equals 74. So the sum of the squares is 74. So now this x squared becomes this. 12 minus x squared is 12 minus x times 12 minus x. That is 144 minus 24x plus 12x squared. In other words, the first times the first is 144. Minus x times minus x gives you plus x squared. And the inner is minus 12x. The outer is minus 12x. So you get minus 24x equals 74. Now we collect like terms. This x squared and this x squared becomes the 2x squared. The minus 24 becomes this. Now we have plus 144, and we're going to bring the 74 from the left to the right. From the right to the left. So plus 74 becomes minus 74. 144 minus 74 becomes plus 70. Now I'm going to just divide through by 0. Divide through by 2. Sorry, I'm going to divide each term here by 2. I can do that. So 2x squared divided by 2 gives me this. Minus 12 24x divided by 2 gives me minus 12x, and plus 70 divided by 2 gives me 35. And this factors now into x minus 7, x minus 5. Notice the first times the first gives me the x squared, minus 7 times minus 5 gives me plus 35. And the inner is minus 7x, the outer is minus 5x. If I add minus 7x and minus 5x, I get minus 12x. So the first number is 7, and the second number is 12 minus 7, or 5. So I get the same solution if I choose x equal 5. So there's a multiplicity, but the numbers are 7 and 5. Now I check this by squaring 7 squared plus 5 squared, and that's 49. 7 squared, 5 squared is 25. 49 and 25 is 74. So we know we have the right answer. A girl, in number 22, we're told a girl is 5 years younger than her older sister, and the product of their age is 204. Find their ages. So let's let the older sister equal 5. Let the older sister equal x. The younger sister is 5 years less, so we write x minus 5. Now, it doesn't really matter if you made this x plus 5 right here and this x. So it always works out. You'll see, even if you do it a different way, if you've given the right variable to each term, that's okay. So the older sister is x. If we subtract 5 years, we're going to get the younger sister. And now it says the product of their ages, so I have to multiply x times x minus 5, which is this, is 204. So I'm multiplying the older sister by the younger sister, and I get 204. By distributive rule, x times x is x squared, x times minus 5 is minus 5x. I bring the 204 from the right to the left, and I get minus 204. And now I can factor this as x minus 17 and x plus 12. You'll see the first times the first gives me x squared. Minus 17 times plus 12 gives me minus 204. And the inner is minus 17x. The outer is plus 12x. If I combine those, I get minus 5x. Now, I agree with you that it's not easy to see the factors for this. It takes a little bit of time. But for example, you could say, well, what if I chose 4 and 51? 4 times 51 gives me 204. But there's no way I can combine 4 and 51 to give me minus 5x. So I have to look for, and even if I take 2 and 102, that's not going to work either, because I'm not going to be able to combine 2 and 102. So I have to look for numbers that are more close together so that their difference only gives me 5. In this case, it happens to be 17 and 12. Now, ages can only be positive, so x is 17. This is the only solution. We can't have an age that is negative. So we take 17. The older sister is 17. The younger sister is 12. Their product, 12 times 17, is 204. Now, in problem number 23, we find x in each of the following. In part B, we're told we have a rectangle here. So this is a rectangle. And one of these is the length and one is the width. It doesn't really matter because the product of the length times the width, whichever we say, doesn't matter whether it's which one we establish because it's a product. So this times this should give me the area. So I get 18x minus x squared when I use the distributive rule. x times 18 gives me 18x. X times minus x gives me minus x squared equals 80. And now what I'm going to do is just bring everything from the left to the right. I'm going to bring everything from the left to the right. So this will become plus x squared, and this will become minus 18x plus 80 equals 0. So I get everything on one side. You can move this to this side and then multiply through by minus 1, but the object here is to get a plus x squared. It's easier to see the factors. So I moved this over to this side, and I moved the 18x from the left to the right, and then I just move the position of the 0. Instead of having 0 equals this, I put this equal to 0. So now the factors, okay, that first of all, if this is negative and this is positive, the factors have to be negative, negative. And you could use 5 and 16, okay, but there's no way they would sum to give you 18x, so you have to use 10 and 8. So minus 10x is the inner one, minus 8x is the outer one. That gives me minus 18x. X times x gives me x squared, and minus 10 times minus 8 gives me plus 80. So there are no other factors that you can use. So you could say, well, what about 4 and 20? Well, you can't combine 4 and 20 to give you minus 18. So x could be 10 or x could be 8. Well, if x is 10, 18 minus 10 is 8. So you have 10 and 8, and if you reverse it and you make this 8, then this has to be 10. So we check the answer. One of the dimensions is 10. The other is 18 minus x, which is 18 minus 10, which is 8. And the product is 80. So this is the only product. You can see, for example, supposing I choose randomly 4. 18 minus 4 would be 14. 4 times 14 would not give me 80 squared. So whatever I have here, I can make this 10. This has to be 8. 10 times 8 is 80. If I make this 8, this has to be 18 minus 8, or 10. I still get the same answer, 80. The last problem that we're going to do here on page 73, we're given this triangle. And just to remind you, this is 90 degrees, so we call this the height or the altitude of the triangle, and this is the base. So this represents the base right here, and this represents the altitude. This represents 90 degrees, so we know that this is the height or the altitude, and we know the total area. Now the area of a triangle is the base times the height over 2, or sometimes we say half the base times the height. But if we say a half, we're really putting a 2 here. So we know what this is. The base is 3x minus 4. The height is 2x. So we're just substituting for these in here over 2. Now, because of this 2, now I want to get rid of this 2, so I'm going to multiply both sides by 2. 2 times 4 is 8. And if I multiply this side by 2, this 2 will cancel, and I'll just be left with a numerator, 3x minus 4 times 2x. Okay, so then what do we do next? We multiply by the distributive rule. 2x times 3x gives me 6x squared. 2x times minus 4 gives me minus 8x. Now I'm going to bring this over to the other side. In other words, I'm going to put this on this side and put this on this side. And because I'm doing the same, I'm just reversing the sides. There's no change in signs involved because I'm working with both sides. So now what I do is I transpose the 8 from the right to the left, and it becomes minus 8. And now what's the greatest common factor here is the number 2. I can take that out of there. So I get 2, and 2 times 3x squared gives me 6x squared. 2 times minus 4x gives me minus 8x. And 2 times minus 4 gives me minus 8. So using the distributive rule on this, I should be able to go back to this line. Now I'm going to factor this right here. And it factors 3x and x, and plus 2 and minus 2 here. So the first times the first gives me the 3x squared. The plus 2 times the minus 2 gives me the minus 4. And the inner is minus 6x. And, the outer is minus 6x. The outer is minus 6x. And the inner is plus 2x. And they sum to give me 4x. So now I'm really, since x can only be a positive value, I can't have x being a negative value. I'm not really interested in this solution right here. This would give me x equal to minus 2/3. But the only one I'm really interested in is this, because it gives me a positive solution. A distance cannot be negative. So the only interesting one is x equals 2. If I take the area equals 3x minus 4 over 2 times 2x, which is the original equation right here, and I substitute the x equal 2 in here, 3 times 2 is right here, minus 4 is right here, and 2x, where x is 2, is 4. So this becomes 6 minus 4, which is 2. So that 2 cancels with this 2, and I'm just left with 4. So you could do it. You could say 6 minus 4 is 2. 2 times 4 is 8. 8 divided by 2 gives me 4. So it doesn't really matter which way you do it. So this completes our discussion on problems on page 73.